In this video, we're going to graph the function f of x is equal to x squared minus 7x plus 12, and we're going to identify the minimum point. So some of you may just factorize at the start. I'm just going to identify this plus 12 here. You can see plus 12 is not on this graph, and that's why we're going to sketch it. So it's going to come up past this 6. We're going to identify something else about this. If you looked at graphing Quadratics 2, you would have noticed that the points, one of them was over this side of the y-axis and one of them was over this side. In this video, they're both going to be on the same side and they're both going to be on the left. In the next video, they're both going to be on this side here, the positive side of the x-axis. So let's have a look. Factorizing, we're going to get x times x. I'm going to put equals 0. To get 12 and 7 in the middle, we want 4 times 3. Your brain should be saying 4 3s are 12, and 7 should be jumping into your head when you're saying 4 and 3. For 7 to be a minus, both of these have to be minus, which would give a minus by a minus to be a plus 12. So these are my factors, my roots. So what we do is we let both of these brackets equal 0 technically, but you know that what happens is this sign changes and the 3 goes on top of whatever coefficient of x, in this case just 1, so 3 over 1 and 4 over 1. So x is equal to 3 and x is equal to 4. As you can see here, we're looking at the positive side of the x-axis, 3 and 4. So they're very, very close together, which will always be the case when the roots are 1 apart. Now, what about the minimum point that we introduced in the last video? The minimum point, it's the midpoint of the roots. So the midpoint of the roots is 3.5. So what happens if x is equal to 3.5? So what we're doing here, we're subbing back into f of x. So I'm going to write it as f of 3.5. If you jump up, this x has now become 3.5. So all the x's become 3.5. So 3.5 squared is this one, minus 7 by 3.5 plus 12. Now, try and estimate a value here. Is it going to come all the way down here? That would make the graph very, very tight. Or is it going to be closer to the 3 and 4 up here? So come up with an idea there where you think the answer will be before typing this into your calculator. And the answer you'll get here, it has to be a minus, doesn't it? Minus 0.25. So you were correct if you said yes, because of the closeness to the roots, it's going to have to be up here in this direction. So minus 0.25, just down a tiny bit. So if we do the curvy bit first, it's going to come down like this. And this is all we have so far. So would normally look at this 12 here, but because we don't have the 12, so the easy thing to do here is let's let x equal 1, and you should see the answer here. We have a 1 plus 12 is 13, take away 7 is 6. So 1 and 6. 1 goes up to 6. Now, your guys' knowledge of the symmetry of quadratic graphs, we've come across 2 from 3. So if we go across 2 from 4, the symmetry of quadratics tells us that if we put 6 in, we should get 6 up here as an answer. So let's check. 6 squared is 36. Minus 7 times 6 plus 12 is going to be 48 minus 42, which is in fact equal to 6. So the symmetry of the quadratic gives you 2 more points here that we're then able to continue our sketch going up in this direction and up in this direction. You wouldn't put these lines in yourself in an exam, but just to show you in this video how to make your graph kind of move to the left and move to the right with other points that you aren't necessarily asked to find. So give this one a go now, where the quadratic is on the positive side of the x-axis, and in the next video we'll look at where they're on the negative side of the x-axis.